Today in the workshop I shall be making a woodworker's marking gauge. Now this is a really handy tool for laying out all kinds of jobs in woodworking. You can do dados and rabbets, you can mark out mortise and tenon joints, you can mark out dovetails and many more things. It's quite a simple turning job on the lathe, and I'll be taking you through the process of how I made it from start to finish. I'm going to be turning this out of solid brass today, so the first job is to break out the bandsaw and lop a great big lump off this hex bar stock that I've got. The stock itself measures just over 2 inches across the flats, that's 52mm, which should be plenty big enough for this project. The other thing I'm going to need is some stainless steel bar stock for the central shaft, and I'm using this piece of 8mm here. The only other thing that we need are these little cutting blades, and I bought these I think from Amazon. They came in a pack of 2 with a little fixing screw. So the first job over at the lathe is to face off the stock on both ends. This insert that I'm using here is specifically for brass, and I'm quite pleased with the surface finish that it's leaving. Next up, I'm going to be drilling an 8mm hole all the way through the workpiece to accommodate the shaft. I should really be using a reamer for this, but I don't have one to hand, so I'm going to make do with the drill bit, and I think it will work just fine. If you're working in an imperial, then 8mm is about 5/16, so you could quite easily substitute for a 5/16 shaft here if you wanted to. Over to the mill now to drill the cross hole for the locking knob, which will lock the shaft that holds the cutter to the body of the tool. Of course, you could do this after turning the main body of the tool. I just figured it'd be easier to hold in the vise if I did it this way round. What I'm doing here is edge finding both sides of the vise, and then I shall use the half function on the DRO to find the centre point. This should mean that our cross hole is directly centred on that shaft. Now that's the only real critical dimension in this operation. The distance from the end is really just aesthetic, so you can set that to whatever you want. I've chosen to drill and tap this cross hole M6, but if you use an imperial, then maybe a quarter 28 or quarter 40 would be a good substitute. Back over to the lathe now to turn down the main diameter for the handle of the tool. None of the dimensions here are critical. I turned mine to about 70mm long, which is about 2 3/4 inches, by about 26mm in diameter, which is about just over an inch. But again, you know, it's really up to you, whatever fits your hand well. As you will have undoubtedly noticed by now, I'm turning this out of a solid piece of bar stock, most of which ends up in the chip pan. Now, given the current price of brass, that's somewhat upsetting, so in hindsight I probably should have turned these out of 2 bits of material. I could have turned the handle and the head of the tool separately and just joined them together with a screw thread or a press fit and Loctite. Now that's the handle turned to dimension, and I'm just winding the cross slide out here to face the top of the head of the tool. And now onto the decorative features of the handle. I'm just using a little round-nosed form tool here to put some grooves in. These are going to look good, but they're also going to give us a better grip on the handle itself. I'm plunging in here about 1mm, which I think is about 40 thousandths, and I'm going to be spacing the bands at about 7.5mm all the way down the handle. Going to be finishing this handle up with a little chamfer on the end there, just to make it look nice and also to make it feel a bit better in the hand. Now I need to turn this round in the lathe to work on the head of the tool, and I don't want to damage the handle that I've just turned, so I'm wrapping it in some aluminium drinks can here, which should in theory protect it from getting marred up in the chuck jaws too much. I'm using a 45-degree chamfer tool here just to take the edges off those flats on the hex. Now the reason for using hex stock in the first place is so that when you set the tool down on the bench it doesn't roll off. Now you could of course use round bar for this project, no problem, but if you are going to do that I would mill a flat into one side at least. I'm boring a recess into the face of the tool here to allow the cutter to retract back into the tool for storage. Now in hindsight I made this way too big. It only really needs to be slightly bigger than the cutter itself. This is because you want as much bearing surface as you can along the face of that tool so that you've got a good platform to run along the reference edge when the tool is in use. I'm machining the end of the main stainless steel shaft here to accept the cutter. Now, when I ordered these cutters, the dimensions weren't actually specified, and when they showed up, they were a bit smaller than I expected. So I've just undercut the end of the shaft there just to make sure that the cutter's got enough clearance. And I'm just drilling and tapping the end of the shaft there to accept the screw that will hold the cutter in place. On to making the knurled knob now that will screw into the main handle and lock down on the shaft to lock it in place. The size of this is not crucial, but I made mine 1 inch in diameter to make sure I had enough leverage on it to give it some gronk. And I'm back to using my knackered old Chinese knurling tool here, which I'm not happy with. Leaves a really awful finish generally, but it'll have to do until I get around to building myself a new one. I'm turning this down to M6 to match the hole that I put into the main handle earlier on. As I said before, the thread isn't important. You can use whatever's convenient. If you're an Imperial, I'd probably use a 1/4 28, but that's entirely up to you. I'm just going to chamfer the end there just to give the thread a little better chance of starting, and I've chamfered one side of the knob there before I part it off. I'm going to go in a little way here and then come back in with the chamfer tool just to finish the other side of that knob to make it look equal. To finish this part off, I've just flipped it around in the chuck and I'm coming back in with this round nose form tool just to create a little fillet across the face there, just to make it look a little bit nicer. So that's us finished. All we need to do now is put it together. So it's simply a case of inserting the shaft into the main handle and screwing in the locking knob. So I'm quite pleased with the way this has turned out. It's got a really nice action actually. Despite having not used a reamer, it's just drilling it seems to have worked out just fine. And that locking knob's got a really satisfying kind of positive action to it and locks onto the shaft surprisingly well. So I think it's high time we gave this marking gauge its first test. So the nice thing about this tool is it's dead easy to set to the exact thickness of a board, as you can see I'm doing here. And as you can see, that's bang on. I've managed to find these extremely rough looking pieces of timber in my shed, and what I'm going to do here is score the end and try and make a rabbet joint. I find it's best to make several passes, several light passes. I think you get a bit of a cleaner line like that, rather than trying to dig it right in and tear across the fibres. It seems to cut better if you do it in several light passes. So what you end up with is a nice clean line across the grain that you can fit your chisel into to start your joint. If you haven't guessed already, I am a complete novice when it comes to woodworking, so please do forgive the awful looking joint here, but I hope that it does demonstrate at least that the marking gauge does give you an accurate cut depth there. We've got a nice flush side on that and a nice clean line along the top. Now, of course, I'd be out of my mind if I left that ridiculous recess in the front, so I've loaded it back into the lathe and I'm going to remove that now. I found when I was using the marking gauge, it was wobbling around a bit because of the lack of material in the centre of the disc there. So I figure if I remove that, it should work a lot better. And of course, I'm going to need to re-chamfer that edge. Just trying to sneak up on it here and make it look equal on both sides. And of course, now it's not got the recess, the blade won't retract all the way into the handle. So I'm coming in here with the boring bar and just very lightly chamfering that that hole there to allow the blade to just recess enough just to sit flush with the bottom of the face, so it will sit nicely on the shelf. And I'm actually really pleased with the way that came out. One final test now, and it is working much better actually. It's much more stable. It's got a lot more surface area on that face in order to engage with the reference surface of the workpiece, so I'm really pleased. So that was another really fun little project. Didn't take me too long in the end. I think I spent 2 or 3 hours on this end to end. If you're considering making one of these and you'd like some plans, please let me know in the comments, because if there is enough interest, I'll consider drawing some up and publishing those. Now, I've got a whole bunch more tool making projects like this planned for the channel, so if you think you might be interested in that, then please do consider dropping me a like and a subscribe so you don't miss out on those, and I shall very much look forward to seeing you in the workshop next time. Thanks for watching.